3D printing your own car parts might look fun until you realize how easy it is to mess things up. So in this video, I'm going to show you the top 5 mistakes I've made and how to get a nearly perfect car part print every single time.
So when I first started 3D printing my own car parts, the first mistake that I made was picking the wrong filament.
And with dozens of choices, it can be pretty easy to mess this part up.
But knowing where you're going to be putting your car part inside your car is key, because not all filament acts the same when it comes to heat.
Now the good news is all filament manufacturers list the details in their technical data sheet, or TDS for short. And the first thing you'll want to take note of is the glass transition temperature, which is the temperature in which the plastic starts to soften. This is different than the nozzle temperature, which is what the 3D printer nozzle has to be in order to properly print your part. But some manufacturers like Bambu Lab don't list the glass transition temperature, so instead you can look at the heat deflection temperature, because it's the temp in which the part will start to deform under a specific load. But for my first car part, I used PLA filament, which has a heat deflection temp of around 130 degrees Fahrenheit, and after testing the part on a cool sunny day, the part started to sag.
So you're probably wondering, what type of plastics do car parts use, and why don't they melt? Some car parts use polypropylene or PP, as well as ABS, which is the same filament that Lego is made out of. Now, PP doesn't work that well 3D printing, so you can use ABS. However, the ABS that you typically find in cars has additive UV protection.
So for 3D printed car parts, I prefer ASA filament. It has a heat deflection temp of around 212 degrees and is UV resistant.
And it's also water resistant, so you can use it for parts that'll be on the outside of your car as well.
Now that we have the right filament, here's where mistake number 2 comes in. Since ASA requires more heat to print, a 3D printer without an enclosure just isn't gonna cut it.
Now, if you're worried about how much an enclosed 3D printer can cost, don't worry, because there's printers like the Centauri Carbon here, which is pretty affordable and has lots of great specs for around 300 bucks. But if you're printing in a colder environment like a garage and want even bigger car parts, then I would recommend the Bambu Lab H2S. The build plate is much bigger, and what I also like about the Bambu Lab H2S is that it has a built-in heated chamber, and that's going to keep your car parts nice and warm, especially for larger prints that might take much longer to print.
I also like to use a fume extractor when printing, and you'll also want to pick up a filament dryer. ASA and other filaments love to wick moisture, which can ruin your prints. So get yourself a standalone filament dryer or the AMS2 Pro with the H2S from Bambu Lab. It has a built-in filament heater, which allows you to dry up to 4 rolls of filaments all at once.
But now that you have the right printer and the filament, what else could go wrong?
Something like this, which is mistake number 3, bad settings. The way to fix this is changing some of the default filament profile settings both Bambu Lab and Centauri Carbon include in their 3D printing software. When printing ASA for car parts, I like to keep the printer as warm as possible. So on the H2S, a good setting to have for the heated chamber is the max temp of 65 degrees Celsius. And on the Centauri Carbon, I like to keep all fans off, and I like to set the bed temp to the max. This way the printer can warm up through the build plate since there isn't a heated chamber. Another setting I like to add is a brim, which is extra filament on the inner and outer walls of the print. This helps keep the first layer from warping off the bed.
Here's an example of a part coming right off the build plate. This part is very thin and doesn't have a lot of contact to the base plate. Here's the same part with the brim added, and it successfully completed its print with no issue at all. The layers of the brim have added a nice stable base for this particular print, and that helps it stick to the bed without coming right off. And here's also another part that we printed on the Centauri Carbon, and you can see how printing on the base of the build plate gives this part a nice textured look.
Now this fourth issue can cause all sorts of random problems, even issues that give off a funky wave pattern on your 3D prints, and that's proper maintenance. so make sure you're lubricating your printer on a regular basis. I recommend following the 3D printer manufacturer's directions with the correct oil and grease to make sure you're applying each correctly to the right parts of your 3D printer. The second issue could be due to loose belts, which usually includes checking the tension and proper tightening. And don't forget to run a calibration test after maintenance or moving your printer to a different location.
Now this next topic is one of the most debated topics I've seen about 3D printing car parts, or any parts for that matter, and that's how to clean the build plate. And sometimes what you'll notice is on your build plate, you'll see a bit of residue from other types of prints. On this build plate, I just printed some Gridfinity, and let's see, can you see there's a bit of residue left from the PETG filament that we used on the build plate. Now there's all kinds of suggestions, but what I would recommend to do is just follow the manufacturer's guideline. So if they tell you to use some water and soap to clean the build plate, then that's what I would recommend doing. And also another tip for maintenance, if you have filament that ends up stuck to your build plate, throwing it in the freezer for a bit and then taking it out does help to remove that stuck filament. So I saved the best for last, and this is one of the biggest problems that I run into even after fixing everything else, and that really boils down to poor design. In this particular radio delete plate, these clips are super tiny and they can snap super easy. Now, printing this at an angle won't help either because the design just has very, very thin clips.
One option to fix pre-made car part designs found online is by adding a cube in the slicer software. You can scale down a cube and drag it over the part you want to beef up. Once you have the right size, you can copy the cube to another spot. This will add more material to the weaker parts of the print, but this process can be pretty painful.
So if you want the perfect car part, sometimes you just have to make it yourself. Now that might seem a bit intimidating, but with software like Shaper 3D, along with an iPad and an Apple Pencil, you can whip up designs pretty easy. And if you're interested in how to design your own 3D printed car parts, watch this video series up next here.